Hey, what's going on, guys? Z here. In this video I'd like to tell you about the toughest data extraction job I ever had in my life. So let me first describe what should have been done, and then quickly walk through the steps I've been through, and then finally show the end result of this sort of a job. So I got a request from Van Houten, which is the maintainer of CNCinEnglish.com website, a very fantastic resource on regarding regarding Chinese chess, how to learn to play as a human. Really, lots of articles. We've been working together for quite a bit of time. I've created some embedded CNC diagrams for his website, like to play CNC and also to solve puzzles, but that was really a piece of cake. Now what's really tough, now the really tough kind of task Howden gave me was to convert, was to parse this sort of a format. So this, what you see now on your screens is known as the Ubb format. I have no idea what does it stand for, but this is the encoded version of the game of CNC that is used by the site don'tpincnc.com. This one. So as you can see here, that the initial board position is encoded, as well as the move list, which is the main line, and also the variations are encoded. And my very first attempts, I was trying to decode this manually and then try to grab all this stuff together, but that failed because I didn't find a way to initialize the board position. So eventually I went for completely weird approach, but surprisingly that weird approach actually resulted the best so far. And I don't even know how many times I was losing my hope entirely. So I was giving up this project countless number of times, but still it seems like that eventually it kind of works, more or less, at the list. So if we just take this UBB game and go to a dynamic board generator at the don'tpincnc.com, and we just paste this right over in here and click this, convert UBB to HTML, and then copy. And then not sure that I'm doing this in the proper way, but if I just say document.write and paste this stuff in, I'm sorry, not like this, and paste this stuff in, then it generates a so-called dynamic, they call it dynamic CNC board, dynamic HTML board, dynamic DHTML CNC. And here we can click through the game, and also if the variation occurs, we can click through the variation. So I've used this app as the basis for my data extraction solution, and eventually here is what I've built. So the app itself, so this is the extended version of the app. I don't really need this part, but here is the deal. So it was only capable of printing the main line here, okay? So only the main line, but no commentaries and no variations. So what I did, I've written a script that is embedded to this don'tpincnc dynamic HTML generator that walks through the moves, extracts commentaries, extracts variations as well, and dumps this all together into a single file. So first, just to give you an idea of the actual game that I needed to parse here. So this is called 7 stars endgame. It's actually, yeah, gathering of 7 stars. So here is the UBB code for it. So you see like really fantastic number of variations. You see like this is really huge file here we have. And not only several variations, it also have nested variations that have nested variations with side variations. So it's total hell basically. But eventually I did manage to convert this sort of a file to this sort of a file where we have a linear, so it's just to give you an idea regarding the amount of lines being available within this file, so more than 2,000 lines basically. So here we have this sort of a game or analysis in the format of a book, which is actually the goal of Fan Haodin, who is writing books apart his other work on CNC. So here is the idea that we kind of like reading through the book. So we have the first move, associated commentary, and we go walk through some variations occurs and all this analysis. So it's just like you're reading a book here. So that's kind of how it works. Okay, so now I will quickly show you how this works with a simple example game. First, I'll describe the algorithm, then I'll demonstrate this in kind of slow motion. Let's call it slow motion, right? Then I'll demonstrate how it works on the real deal, and then finally I don't know, I don't even want to show you the source code because it works, but oh, that was so tough, and the source code doesn't look that great. But anyway, so let's grab the game. Let's grab the example game here. And I just update the page and paste. So first, the user interface. So I've added to view elements. So the one where to paste the UBB code, and the second where the converted game would be displayed. And also this big button to actually run the script. So here we have a game, and here what has just happened, it just walked through all the moves that are available there. So I will now demonstrate you this with the mouse to give you an idea. So it starts with the first move. Okay, so first move being extracted, then we have the associated commentary. It extracts the commentary, then we walk in further on within the line, walking until here where the variation occurs. And now we go into the very first move. So the first variation, rook 1 equals 2. So this is the first, this is variation A, the associated commentary, variation 1. And then we walk through the moves of the variation until this one, h7 minus 8. And here we have a commentary that this is the end of the variation 1. So then we need to drop back, and then we need to pick the second variation. So we have variation B, h8 plus 7, the move associated with it, the commentary associated. Then we walk through the moves, h2 plus 3, so on, until rook 9 equals to 8. So walk through the variation. Here we have the commentary, embedding the commentary, going back, going to the variation C, in this case, rook 9 plus 1. And here we have another variation until the commentary, and then dropping back, and then we go through the main line. Okay, I'm sorry, no, and now we drop back here, yeah, and now finally we we're completing the main line up until right over in here where we have the end of the main line. And this is the very simple game. Well, the moves doesn't make sense here. I just try to make some tests to debug this app. The debugging was the most extensive phase. I've spent 3 days. I was working around 12 hours a day, basically, feeling completely exhausted. Feeling completely exhausted. I felt like I'm giving up, like countless number of times, really. This was really the toughest stuff. Well, not because it's so hard, but probably because I'm so stupid. I don't know. That's how it goes. You know, like it's quite pretty trivial to do something when someone has done that before, and when you don't really need to invent the algorithm from scratch. Not even inventing the algorithm, but just you don't need to describe it. So I'm used to work with the existing code snippets, ideas, and so on. But here, the most tough thing wasn't the coding really, but the toughest thing was actually to use my brain to figure out what would be the particular logic of traversing this entire game tree, which looks absolutely weird. and how in particular this can be implemented assuming the current architecture of this dynamic HTML CSS viewer. So that was the toughest thing here. So what I've just done with the mouse is now being automated. So if I just give a slightly bigger delay, so you just know that I'm doing this asynchronously. If I'm doing this synchronously, it goes for it exhausts. Oh my god, I forgot how they're called. To me, how? Forget that. It just gives errors. So that's the reason why I'm doing this asynchronously. One of the errors, and one of the reasons, and another reason is because it's just cool for user to see how the pieces are moved. So if you just give 500 milliseconds, which is half a second, and I just make this again from scratch. Now we can enjoy the show. So it walks through the moves and extracting the stuff along the way. Then it goes through the variations. Okay, then it goes variation 2 and then it goes variation 3 and all the stuff being extracted. Then it goes here, goes back and returns to the main line, and this is it. So just to give you a visual explanation of how this kind of works. And in order to parse this 7 stars endgame, it takes really lots of time. So I just copy this, and probably I can talk through the code and this would still be processed because there's really big data there. Okay, so let me just drop back to 0. Okay, and now I just update this stuff and paste the 7 stars endgame and sit back and enjoy the show. And now I walk through all of the variations, and at the same time it extracts kind of like all the data that we need to have here and so on. So this takes quite a bit of time. So by the time it's working, I can really go through I can really try to walk through the source code. So everything that goes up to this UBB to TXT parser is the code from dynamic HTML CSS viewer that you can see right over in here, and all that goes down below here is my code, my script intended to see exactly what happens, to make what you can now see on your screen, what happens now. So literally automating the process on clicking through the moves to extract all the moves, all the variations, all this stuff. I don't know, probably this is too weird, and probably there was a much easier way of doing things, but I just don't know how else this could have been done. So click back is literally a move stack. So I'm just pushing and popping this moves back and forth. That's how I deal with the nested variations basically. And also I'm associating, so when I push to the stack, oh my god, where this happens, yeah, here, I'm not only pushing the move ID, which is the div ID literally, but also the move count, which is the relative counter that gives an idea regarding this. So this happens recursively. So function process, you see, like it goes recursively. So it goes through. So like how it thinks. Just I'm sorry guys, I'm just so exhausted. I don't even know how to explain this. So the idea is that in a normal kind of like tree traversal, we have the main line, and then when the branching occurs, we just sidestep and then go to the line, return, sidestep, go to the line, and so on. But here it's a little bit different. So we go through the main line, and then let's say here we have the variation. So when this variation occurs, it becomes the main line. Okay, so we kind of like completing the main line numerous number of times. So see, like it happens all the time. So every time I'm completing the main line, and then when the main line is completed, this clicking on either next variation or clicking on go back to the previous variation if this was a nested one occurs. And then so every time we did complete the entire kind of like main line. It's not a main line, but it's treated to be a main line from the perspective of this recursive algorithm. So every time we complete this move list, we just adjust the click to drop back to appropriate variation, and then we start this again. So it's kind of like we just completed all the moves, then we drop back, and then we just switch another, complete, then drop back, then we switch another, complete, drop back, and so on. Then probably so that's how it works. I don't know, probably I know this explanation sucks basically, but yeah, that's what I done basically. So I don't even know what else to say. By the way, yeah, it's still processing the game, so it's really time consuming. So again, like probably, I don't know, it might seem really weird, but we have what we have, and I'm not that smart enough to actually make it better basically. But you know what, guys, this is the most satisfying data extraction project I had so far. I have a rich background in web scraping. I've been doing that for a couple of years, but I never ever had this like complicated data extraction task yet. And the toughest thing here was actually to invent from scratch, like how in particular we're going to be proceeding for this data extraction logic. So again, like reusing this existing software was the key, was the pivot point basically. And only after I've managed to do this, okay, so finally we are done. So I just want to check if the length is the same, because otherwise it takes ages to check everything else. So I was checking the logic on smaller chunks, but let's see. So it should be 3,353, something about like that. Oh, 2,353, and here we have 2,353. Yeah. So just to give you a very quick idea, like how the real game is getting parsed. So we just go to, so see, like now it's in the main line and at the very last move. So it starts from here, so red tries to checkmate, and here we go, and up to move 4 we don't have any variations, so we go in up to these are just the commentaries. Yeah, and here is the first variation, so variation A, so rook 2 plus 9, and this is the variation. This is the variation. Then we drop back and go in plus pawn. Yeah, this is dropping back to the main line. Okay. Then going up until here. So this move is key for black, the commentary, and so on. So I've been walking through this really numerous times, and within this 3 days, I've been watching how it automatically picks every next move, really countless number of times. And you know, like a very interesting thing that today in the morning, I lost the hope to complete this project ever completely. And the only reason motivating me to keep going was I thought like I just need to make sure that I did everything I could do. So I wasn't always, so the previous 2 days I was really I had a desire to get the result, but this morning I lost the desire completely, so I wasn't care about whether it works or not. Absolutely, I didn't care. I've stopped caring about that, and I just tried to make anything I can, and then suddenly it started to. So when I released the tension of trying to get the results, suddenly I've started to dive deeper into this process and started to realize how it works basically and what I could change. And then I started experimenting, and eventually this is what I came up with basically. So if we have a very quick walk through the code, so we have this recursive function, this function process, which walks through all the variations, all the moves, including the nested variations and all this stuff. So literally the single function here, and it's called recursively. It's done down below here, okay, asynchronously, okay. So I'll try to describe the overall traversal algorithm without diving into the deep details, because I'm just really tired to explain that. So the move list is the div element for, this is the move list, okay, this is the move list, and the move is the element of this move list indexed by the count. So count is the count that we pass recursively. So this is gonna count 0, count 2, count 1, 2, etc. But actually they walk not one by one, but 0, 2, 4, 6, 8, etc. So they walk, they jump over 1, but that doesn't really matter that much. So the first condition, so every time we hit the end of either the variation or the game, then we need to take a decision on what we're going to be doing next. So we, well, all this code is literally to, so we need to click back to the move where the variation occurred. So let's say we walk through the variation, so click, so we end here. So before proceeding, we need to click back, okay? We need to click back, and actually if we were here and if there are no more variations, we need to drop back. But let's say there might be a case like in this one. So let's say here. So in this position, we can either drop back, but actually we want to go further on until we hit the very last available variation. And when we hit the very last one, then we need to drop back to get back to the main line. So this piece of code actually does this. So clicking through the next variation. So I'm using a pretty weird way to get the index of the current variation by picking up the element that is highlighted. This RGB background color is literally, so I'm getting, so let's say here I'm just getting the index of the highlighted element, then I increment this highlighted element to get the variation count for the next element, and then I click through it. So I just mimic two events on mouse up. On mouse up event lets us to switch through the main moves, and click actually allows us to click through the variations. I don't know why they use on mouse up. So I think it would be okay to use click in both cases, but probably because they also support this arrow keys in order to walk through the move list. That's what they done for the GUI on downpin.cnt.com. Okay, so here we just take a decision whether we go to the next variation, or if it's not available, then we just click the very first node. So we just go into the main line, or if this is not a main line, we go into sub variation back, and also we pop our click back move stack here. Okay, and another thing, well, it's a little bit hacky, and probably I don't know, this could have been done much better. So another condition here. So if move is move is equal to undefined, this in general case this means that no moves in the move list are available anymore. But here we have no moves in the move list are available, but still we have the length of our move stack is not equal to 0, so we have the moves. So we have somewhere to drop back, so we didn't yet end the main line. And here it should be like we completed the entire game. But this happens in this horrible 7-star end game. It happens that we several times within this traversal we encounter a situation where we have the move undefined, but at the same time and the move stack has been exhausted, but at the same time we didn't yet traverse the entire tree. And this was probably the toughest thing to track this condition, to track this situation in particular. So what am I doing here? I'm just trying to force the click through either the next variation or drop back to the previous one, to the previous one here, and that's the way how to get away from this that loop basically. And naturally, if click it happens that I'm sorry, not exactly. So here we have the length of sorry guys, no, not like that. So the clickback length is available, but the move is equal to undefined. But it's not always the case. So sometimes we get here, but at the same time we have the click back is not equal to 0, so we still have the moves to drop back. And in that case, we kind of like restart this drop in back, or traverse into the further variation in this part. So this is the duplication, absolutely ugly code. So duplication, so this piece of code and this piece of code, these are the duplications. But anyway, so after we've adjusted the move, here is the main logic basically. So if we have the appropriate move ID to click, then we click it, and then we extract the move number, move text, move commentary, move variation, and then we build in this TXT value is this element that we build in our moves. And this code allows to pick the very first variation every time. Probably a bit of a redundancy as well, but that's where I've started. So here I only pick the very first variation, so it's hard coded to variation A. And then the last thing I've added here is just to map the variation count to the letters. So we have variations A, B, C, D, etc. But no A here because A is hard coded down below. So this is how it works basically. Okay guys, I think this is it from my side. I really need to get some sleep because probably I've never been working that tough like I did this previous 3 days. I don't know what else to say basically, but I really want to say that this is the most satisfying data extraction project I had so far. Because yeah, usually I don't think when I code, because I just follow the patterns, some existing patterns. So I can code and no thinking. that might sound weird, but that's how I work basically. But in this case, I really needed to think a lot, and that was really tough. I'm really bad in thinking. Yeah, that's true. Okay guys, so this is it from my side. I hope you've enjoyed the video. This UBB parser would be published at my UKUNCNC GitHub repositories, HTML pages, so it would be available online for testing. I don't guarantee that this is 100% bug free. It should be generally fine, but you may encounter some bugs in it obviously, because again, like you see the size of the file that was eventually generated, so it really takes ages to check everything by hands. But I'm very happy to send this file to Funhausen, so hopefully he would be able to publish this Gathering 7 Stars endgame book and start selling it, making some money of it. So I really hope this would be beneficial for him. Well, okay guys, so this is it from my side. Thanks for watching. Until the next time, and take care.